We now discuss the solution of a problem from the section probability, and the problem is based on the concepts of binomial distribution. This problem has appeared in Joint Entrance Examination Main held on 24th June 2022 in the session 1. The problem is, if a random variable capital X follows binomial distribution B 33, P such that 3 times probability of X is equal to 0 is equal to probability of capital X is equal to 1, then the value of probability of X is equal to 15 by probability of X is equal to 18 minus probability of X is equal to 16 by probability of X is equal to 17 is equal to. We are given 4 options. Option A 1320, option B 1088, option C 120 by 1331, option D 1088 by 1089. We are given a probability, we are given a random variable capital X, and it is given X follows the binomial distribution B 33, P. That means it's a binomial distribution with 33 trials, and P stands for the probability of success, such that 3 times probability of X is equal to 0 is equal to probability of X is equal to 1. Then we have to find the probability of X is equal to 15 by the probability of X is equal to 18 minus the probability of X is equal to 16 by the probability of X is equal to 17. Now we throw some light on the binomial distribution. The probability of R successes in n independent Bernoulli trials, we have n independent Bernoulli trials, is denoted by the probability of X is equal to R, and it is given by the probability of X is equal to R is equal to NCR P power R Q power n minus R, where P stands for the probability of success and Q stands for the probability of failure, and P plus Q is equal to 1, and thereby Q is equal to 1 minus P. B in brackets n comma P stands for, this n stands for the n independent Bernoulli trials, and P stands for the probability of success. Agreed. Let's get into the problem. We are given a random variable X, and it is given it follows the binomial distribution, and the binomial distribution is B 33, P. That means n is equal to 33 trials in the Bernoulli trials, and P is the probability of success, and Q is the probability of failure, which is given by 1 minus P, and probability of X is equal to R is given by NCR into P power R into Q power n minus R. Given the probability of X is equal to 0 is equal to the probability of X is equal to 1, and write down Px is equal to 0 from this formula, and 3 into probability of X is equal to 0 is in this, put n is equal to 33, R is equal to 0, we write, and we have written here, and is equal to the probability of X is equal to 1, and in this n is equal to 33, R is equal to 1, substitute and write down here. And now this will imply 3 into Q to the power of 33 is equal to 33, C1 is 33 into P into Q to the power of 32. And the cancellation takes place, and 3 ones are 3, 3 11s are 33, and Q power 33 by Q power 32 is Q, Q by P is 11. Now the probability of X is equal to 15 by the probability of X is equal to 18 minus the probability of x is equal to 16 by the probability of x is equal to 17 is equal to the probability of x is equal to 15 is 33c15 into p power 15 into q to the power of 33 minus 15, that is q power 18. And likewise, p probability of x is equal to 18 is written here, minus the probability of x is equal to 16 is written here, the probability of x is equal to 17 in the denominator we have written. Now we see 33c15 is same as is equal to 33c18. Why? NCR is equal to NCn minus R is the formula, and thereby these two things will cancel. And similarly 33c16 is equal to 33c17, cancellation takes place, and p15 by p18 is 1 by p cube in the 1 by p cube, that is p cube will be in the denominator. Q power 18 by q power 15 is q power 3 q cube in the numerator. That means here you are left with q by p whole cube, and here you are left with q by p. So q by p whole cube minus q by p, and that is equal to q by p is 11 cube minus 11, and when simplified we will get 1320. That's what is our answer. And our answer 1320 appears against option A. Therefore, our answer is option A. This is a very straightforward question from the section probability based on the concepts of the binomial distribution. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.